Hello everybody, welcome to week 7. So basically this is the last lecture, and this lecture is on electricity and magnetism. So let me go to the slideshow mode. Okay, so this week we are going to learn about electricity and magnetism, and the lab also is on electricity this week. And next week there'll be no lecture, and you guys are going to post your projects, your final projects. So let's talk about electricity first. So it was like for like thousands of years, um, it was a mystery, and that mystery was called the Amber effect. So what was this mystery, and what was this Amber effect? Basically, people back in very olden times, they could not understand then why this rubbed amber. Basically, amber is fossilized tree resin. Why the rubbed amber could attract pieces of small papers and hair towards itself. So people were not understanding in the olden times, and it was a mystery for thousands of years, that how could a rubbed amber could attract the pieces of hair and small piece of paper towards itself. So you must have seen all these things. Now we understand all these concepts. You must have seen, like, if sometimes you are combing your hair, okay, you're combing your hair, and after you're done combing your hair, if you bring small pieces of paper towards your comb, the comb can attract those small pieces of paper towards itself, and this effect will stay only for a very short time. So now we understand this is all because of um, static charges. So we now understand all these concepts, but at that time people were not understanding these things. So it was a mystery, and it was called the Amber effect. So it was J.J. Thomson. He was the one who could find the solution to this mystery, who could find out how these rubbed amber, how it could attract the pieces of paper. And he found the solution to this mystery by finding the particles called electrons. Okay, so he found these particles, and he found that it was because of these particles this amber was able to attract the small pieces of paper towards itself. It is because of these electrons, because of these particles which are negatively charged. And actually electrons is a Greek word, and so electrons is a Greek word for amber. So because he was the one who found that it is these particles, these negatively charged particles, which are responsible for this effect, um, and he could come up with the mystery of the amber. He gave the name electrons, and electrons basically is a Greek word for amber, and the word electricity came from electron. So basically electron or electricity is Greek word for amber. So to understand electricity, we need to go back and let's go revise the structure of the atoms. We have already done these. So atom is a basic unit of matter, right? The matter is made of these atoms. And what are these atoms made of? As you know, we have already discussed, there is a nucleus in the center, and in the nucleus there is a protons and neutrons, and around this nucleus in the various energy shells are moving these electrons. And these electrons, these are negatively charged, and these protons, they are positively charged, and these neutrons, they don't have any charge. So this is the structure of our neutral atom. And if you remember, we discussed, I think in lecture number 2, that in any neutral atom it has same number of electrons and same number of protons. So protons, they have positive charge, and electrons, they have negative charge. For any neutral atom there will be equal number of electrons and protons. But when any atom loses electrons, so it's losing the negative charge. When any atom loses negative charge or loses the electrons, it becomes positively charged. It becomes a positive ion. because it gets now net positive charge. But if in any atom it gains electrons, gaining electron means it is gaining negative charge because electron is negatively charged. So gaining electron means gaining negative charge. So any atom, when it gains electrons, it gains overall negative charge. So this is the way how ions are formed, right? We have talked about all these things earlier also. And how do these charges they interact with each other? Like charges, they repel each other, and the unlike charges, they attract each other. So which means that if you have two negative charges, okay, if you have two negative charges and if you bring them close to each other, they're going to repel each other. And if you bring one negative, one positive close to each other, they're going to attract each other. So this is the way these charges they interact with each other. Okay, so this is just what I talked about to you. Like if you are combing your hair, so when you comb your hair, um, after you have combed your hair, if you bring that combed hair, this your when you're using this comb, after you have combed your hair, if you take that comb and bring near small piece of paper, your small piece of paper are going to be attracted towards the comb. So how is it possible, and what is going on? So basically, when you comb your hair using this comb, some of the electrons from your hair, they are transferred to the comb. Okay, so your comb gets overall more negative charge because some of the electrons are being transferred from your hair to the comb, and your comb gets overall net negative charge. And then when you take that comb which has overall negative charge, bring it near the paper, in the paper all these charges are oriented like this. All the positives are on one side, all the negatives are on one side, and because of that this end of the paper become positively charged and this end of the paper become negatively charged. Now because your comb has net negative charge, and why it has net negative charge? Because it got electrons from your hair. So because comb is now negatively charged and this is the side of the paper which is positively charged, these paper clips or small piece of paper, they're going to be attracted towards the comb because opposite charges attract each other. But this effect is for very short time. Okay, so that is why it's called the electrostatic charge, or it's called electrostatic effect. After some time these charges are going to be displaced and this comb will not have negative overall negative charge, net negative charge. Now what is the unit of the charge? The unit of electric charge is called coulomb. Okay, so coulomb is a unit for charge, and 1 coulomb charge means 6 billion electrons. Okay, so a charge on 1 electron is 1.6 into 10 to the power minus 19 coulombs. So this is a charge on one single electron. So it's a very less charge. Okay, so 1 electron has 1.6 into 10 to the power minus 19 coulombs of charge. So to make the charge of 1 coulomb, there's a requirement of 6 billion electrons. So which means 6 billion electrons together can make the charge of 1 coulomb. Okay, now next is Coulomb's law. Now what does this law talks about? This law basically tells us when you have two charges, okay, when there are two charges, and if you bring these charges close to each other, how they're going to interact with each other, which means that what kind of forces these charges are going to exert on each other. That is what this Coulomb's law talks about. Okay, it gives us a relationship about a force which will be exerted between these charges on each other. And this is the formula, and this is the Coulomb's law. So this tells us the force which will be exerted by these charges on each other when they come in close contact with each other. So that force is basically the product of these two charges. So Q1 is one charge and Q2 is the another charge. So it is product of these two charges, and it is inversely proportional. So this force is directly proportional to the charges on these two charges, and it is inversely proportional to the square of the distance between them, which means if they are far away from each other, more the distance, less the force. Okay, nearer they are, more force they are going to exert on each other. But as they move far from each other, means if the distance increases, this force is going to be less, this force is going to reduce. So double the distance, force is going to be reduced by 1/4. So this is what is the Coulomb's law. Okay, if the two charges, okay, so this force is directly proportional to the product of the two charges. If these two charges, they are of the same nature, they're going to repel each other. And if these two charges are different, they're going to attract each other. So Coulomb's law is basically relationship giving force between the two charges. Force between two charged objects is repulsive if Q1 and Q2 are same. It will be attractive if these are different. And both objects feel the same force. Distance between objects increases, strength of force decreases. So if the two charges are far away from each other, they are obviously going to exert less force on each other. So this is Coulomb's law. Now these electric charges, they produce an electric field. Okay, so around every electric charge there will be electric field, and this electric field is visualized in the form of these lines of field lines. Okay, they're called force lines or they're called field lines, electric field lines. So these electric field lines always move from positive towards negative. Okay, they always start from positive and goes towards the negative. Now here in this case you can see the two charges are both are positive. So these lines always starts from positive, goes towards the negative. Now because these two charges both are positive, the direction of these lines will be like this. Okay, and these two charges, they're going to repel each other, and these electric field lines, they indicate strength and direction of force of the field. So if these lines, they're close to each other, which means the electric field is strong. If these lines are, you can see as the distance is increasing, these lines are becoming far away from each other. They're very close to each other here. So here the electric field is strong. As the distance increases, these lines become away from each other. Then the field is weak. Okay, so electric field lines indicate strength and direction of force the field exerts on the field of another charge. Point outward around positively charged particles and point inward around negatively. So they start from positive and go towards negative. Lines closer, the field is stronger, and if the lines are further apart, field is weak. So you can see here, if this is a positive and this is negative, these electric field lines, they're going to start from the positive, they're going towards the negative. Okay, so their direction will be like this, and when the direction is like this, these charges, they are attracting each other. So like charges repel each other and opposite charges attract each other. Now the flow of this charge per unit time is called the current, and the unit of current is ampere. So the flow of charge per unit time is current, and so this is the formula to find current. Current is the ratio of charge and time. So charge divided by time gives you the current. Okay, and the unit of current is ampere. Now the current can be direct current or it can be alternating current. Direct current means when the charges move in one direction, like your electronic devices, batteries, solar cells, they all are direct current, or we call them DC. Or the current can be alternating current, in which electric field moves back and forth through the wire. Current flows one way, then the other with the changing field. That is the alternating current or the AC current. Now we need to know some terms, conductors, insulators and semiconductors. So what are electrical conductors? Electrical conductors are those materials through which the charges can flow easily, like your metals, graphite. These are all electrical conductors. Electrical insulators are the materials through which charges cannot uh, flow easily. Examples are your rubber, wood, um, glass. These are all examples of the insulators. Then we have semiconductors. Now the semiconductors are materials which can conduct and insulate depending on the circumstances. Your computer chips, solar cells, these are all examples of semiconductors. Now next thing we need to learn is what is resistance. So resistance is something which resists to the flow of the current. Okay, so resistance is something which resists to the flow of the current, and there are various factors which are responsible or which affect the resistance. And what are those factors? Type of material. So as we just studied, there are some materials through which current, these charges cannot flow easily, right? The so insulators are going to show maximum resistance, and conductors, they have less electrical resistance. So type of material is important and it determines the resistance. Conductors, they have less resistance, and insulators, um, they have a lot of resistance. Now length is also very important. Longer the wire, more resistance, which means if longer is the wire, the current has to go through a long distance, which means there will be resistance. Cross section area, thinner the wire, more resistance, which means the current has to pass through thin wire, very less area for the current to pass, so more resistance. Temperature, resistance increases with increasing temperature. So these are some of the factors which are responsible for resistance. Now what is the electrical circuit? So electrical circuit is a circuit is a circuit basically in which there is one energy source, like your battery or a generator, and the current is going to flow through flow from this energy source, and it is going to reach at this terminal where some work will be done. So here, for example, is a electric bulb. So this is your voltage source, or this is your battery, from where the current will this is a source of current. So the current will be passing from this generator or a battery through these wires and going towards this terminal where some work will be done. And here is the electric bulb, which means this electric bulb should light. So this is your circuit in which the current flows from the energy source and goes to the terminal where some work is done. That is a circuit. Now next we need to learn another relationship which is called Ohm's law. Now what does this Ohm's law tells us? Basically, the flow of the current in a circuit depends on two things. Number one, the resistance, and second is the voltage. Voltage is your energy, right? Voltage is energy which is given by the voltage source. So current in a circuit will depend on two things. How much is the voltage, means how much is the energy, and second thing is the resistance. How much resistance is there to the flow of the current. So these are two factors which are responsible for the flow of current in a circuit: voltage and the resistance. And the relationship between these two factors is given by this law called Ohm's law, and this is the formula. V is equal to IR. V is your voltage, I is the current, and R is the resistance. And the unit of your voltage is volts, and the unit of resistance is ohms, and current is amperes. So this is the relationship of current with voltage and resistance. So current is directly proportional to the voltage, which means more energy, more current, and it is inversely proportional to the resistance. If there is more resistance, less flow of the current. So this is the relationship of current with voltage and the resistance. So current is directly proportional to voltage, inversely proportional to the resistance. This is Ohm's law. Now how to find the power in the circuit? To find power in the circuit, this is the formula. P and power is measured in watts. The unit is watts. Basically power is the measure of how much work is done in the circuit, and the formula is P is equal to I into V. I is current in amperes and V is voltage in the volts. So if you need to find the power in a circuit, you need to know the current, you need to know the voltage. So you multiply current with voltage, you get the power in the circuit. So that's all we need to know about electricity, and you have to do a lab on electricity this week. Next topic is magnetism. Now what is magnetism? So magnetism is basically a property of some material by which it can attract iron or some metal or steel towards itself. Okay, so this property is called magnetism, and it is associated with naturally occurring magnetic material like lodestone, magnetite. All these materials, they have this property called magnetism. And what is a magnet? Magnet is characterized by poles. So every magnet has two poles. So remember that every magnet has two poles. One is north pole, another is the south pole. And here are some more examples of other magnetic material like iron, cobalt, nickel. These are also magnetic materials. Also, like the charges, they have an electric field around themselves. Similarly, every magnet also has a magnetic field around themselves, and field lines go from north to south pole. So the way in the electric charges, the lines move from positive to the negative charge. The magnetic lines, they go from north to the south pole. So every magnet has two poles. So it's like if you have one big magnet, okay, if you break it into two parts, which means you will have now two magnets. Now these two pieces will also have north and the south poles. So if you break this big magnet into two pieces, these new two magnets, these two new small magnets which are formed, they will have two poles, north and the south. You break these two into two more pieces, all these small pieces will have north and south poles. So always remember that this is a very important property of a magnet. They always have two poles, north and the south pole, and every magnet has a magnetic field around itself, and the magnetic lines, these magnetic field lines, they move from north towards the south pole. And like positive charges, like if there are two same charges, if you bring two positive charges close to each other, they're going to repel each other, and you bring two opposite charges close to each other, positive and negative, they're going to attract each other. Similarly, if you have in these magnets also, north always attracts south and south always attracts north. So if you have two magnets and you bring the two north poles close to each other, they're never going to stick to each other because both are north. But if you take from one magnet you take north, from the other magnet you take south, they're going to attract each other. Okay, so the like your charges, like magnetic poles, they repel, and unlike poles, they attract. So this is the way your magnetic field lines move. They always go from north towards the south. Okay, they start from north, go towards south. Okay, so in our at the core of our earth, okay, it is considered that at the core of our earth there's a huge big magnet lying. Okay, so at the core of our earth there is a huge magnet lying, and this is the direction of that big magnet in the center of the earth. This is the south and this is the north pole of the magnet. Okay, so always like you must have heard about the magnetic compass. What does magnetic compass do? It tells us the direction, right? It tells us where is the north, where is the south. It tells us the directions. So basically, how does it tells us the directions? How does that needle moves? It moves because it gets attracted towards the magnet which is present in the center of the earth. So this is the direction of the big magnet which is in the earth center. So this is the south, this is the north. Okay, so when your magnetic compass is actually telling you in which direction is north, it is actually your magnetic compass is actually getting attracted towards the south of the. So this is, see, if this is your earth, okay, let's talk like that. This is the earth, this is the big magnet inside the earth, this is the south pole of the earth's magnet, this is the north pole of the earth's magnet, but this pole is geographic north pole and this is geographic south pole. Okay, this is magnet's south pole, but this is geographic north pole, because when you are on the earth, okay, and your when your magnetic compass tells you this is north, which means when your the needle of the magnetic compass moves to tells you the direction is this direction is north, at that time it is actually, because magnetic compass is also a magnet, it is actually getting attracted towards the south pole of this magnet and it tells you this is north. Okay, and when the magnetic compass tells you this direction is south, it is the magnetic compass is actually itself getting attracted towards the north pole of the earth's magnet. So this is the way magnetic compass tells us the directions. So the south pole of the magnet's compass is our geographic north and the north pole of the earth's magnet is our geographic south pole. Okay, next we need to talk about when these charges they move, like the current, when the current is passing through some wire. Okay, when the current is passing through the wire, it produces magnetic field. Like this is your wire. Okay, this is your wire. When the current is flowing through this wire, it creates a magnetic field around itself. Okay, and you can detect it by using a magnetic compass. It will start like when you have a wire and you pass the current through this, and in this region you bring this magnetic compass, it will start moving, and it's moving because of the formation of a magnetic field here, which means that this wire, when the current is passing through it, it is becoming magnet. It's becoming magnet for short time, and this concept is called electromagnetism. And the shape of the field is determined by the geometry of the current, like through what kind of wire the current is passing. If the current is passing through straight wire, then this kind of a magnetic field will be formed, or if the current can be passed through this loop kind of a wire, then the magnetic field will be created like this. Okay, or the current can be passed through this coiled wire. It's called a solenoid. Solenoid is when this wire is really very tightly coiled, and when you pass the current through this, then the magnetic compass, the magnetic field will be formed like this. Okay, so shape of the field is determined by the geometry of the current. It depends from what kind of wire it is passing. So magnetism. So loops of wire formed into cylindrical coil is called a solenoid. I just told you that this tightly coiled wire is called a solenoid. So current runs through coil, produces a magnetic field. So when the current passes through this coil, it produces the magnetic field around it. Now the magnetic field which is being formed is all being formed because of the passing of the current through the wire. It can be turned on and off by turning the current on and off. So it all depends on the current. So that is, it's called magnetism. And strength depends on the size of the current, how much current you are passing, and also the number of loops. Okay, the last thing we need to talk in this lecture is electromagnetic radiation. Now, what is electromagnetic radiation? Electromagnetic radiation is a form of energy which is emitted and absorbed by charged particles. Okay, so it's a form of energy emitted and absorbed by charged particles which exhibit wave-like behavior as it travels through space. Okay, so it's emitted and absorbed by charged particles which also show wave-like behavior when they passes through space. And this electromagnetic radiation has both electric and magnetic field components. So this is the most important point here. This electromagnetic radiation has both electric and magnetic components, and they oscillate in phase perpendicular to each other and also perpendicular to the direction of energy and wave propagation. So the most important thing to know, you need to know about electromagnetic radiation is they have both electric and the magnetic components. And there is a electromagnetic spectrum, which means electromagnetic spectrum is a range of all types of electromagnetic radiation. So there are different kinds of electromagnetic radiations. So all the radiations together makes a range of the electromagnetic radiation, that is called the electromagnetic spectrum. So here is electromagnetic spectrum. So in the electromagnetic spectrum are included microwaves, infrared light, ultraviolet radiation, X-rays and gamma rays. Okay, so all these rays, including the white light. Okay, the white light which is the only radiation from the electromagnetic spectrum which can reach our atmosphere. Okay, so all these radiations make the electromagnetic spectrum. So all these radiations are electromagnetic. Okay, it includes your visible light, microwaves, infrared, ultraviolet radiation, X-rays and gamma rays. But out of all these radiations, only visible light can reach our atmosphere. Okay, but ultraviolet radiation is also able to reach our atmosphere because of the holes in the ozone layer. Okay, and these holes in the ozone layers are all because we are using a lot of chemicals, and those chemicals are creating holes in the ozone layer, and because of that this ultraviolet radiation is reaching reaching our atmosphere, is passing through the atmosphere and reaching us, and it is responsible for skin cancer. Okay, so that's all we need to know from in this lecture. So I hope you guys are fine. If you have any problem, you're always most welcome to contact me.